about requirements. Right. So requirements. At the beginning of any project, we need to decide what is it that we are going to build, and it's easier said than done, and it's usually fairly hard to agree on what it is that we're going to do. We are humans, and like any human endeavor, it's filled with flaws, right? We can't. We go to a meeting and we all think we knew what we're talking about. We go out and we have different ideas of what it is that we are agreed on, right? And so these processes, when we're talking about large projects, you need to be able to sustain an understanding over long periods of time, and since we are flawed. We have to accept the fact that we will have flawed understandings of the same thing. Also, we have different styles and our own biases and our own perspectives, our own culture, our own a lot of them we're not even aware of them, right? That play into the way we interpret things. Also, our own feelings. Depending from our point of view as a developer or as a business analyst or as an owner, onto the need for any of this, right? Our attitude typically stems from having, being fairly geeky and appreciating technology for technology's sake, and perhaps without any particular context, we just think certain things are cool. Regardless, that a particular solution is cool all in itself, regardless of what problem it might try to solve. Usually, we turn it upside down. We have solutions looking for problems, right? And say, where can we apply this? Well, it turns out there are plenty of problems out there, and ideally, a solution would be stemming from problems, not the other way around. So this caricature tries to capture this. It says, go ahead, start working. I'll go see what we need to do. It's very common that if we're not coding, if we're not slaving away and writing classes and whatnot, we feel that we're wasting time, right? That we feel that we're not being productive, so oftentimes it says, wait a minute, before you start coding, let's decide what it is that we need to build. What is it that we're trying to solve? Requirements. It's a hard thing to come up with requirements, and it's usually the most vulnerable that a project is at. It's where a project is most vulnerable, where things could go most wrong, and we're going to pay dearly later on if we get this part wrong. Okay. Here's another caricature on trying to how difficult is it to come up with what are we going to build? I need you to give me to come up with agree what it is that we're building, and oftentimes we assume that we can read minds, right? That things are implicit, that it's obvious. How don't you know what we need to build, right? And oftentimes the client themselves don't know what they want. Right? Or they think they know what they want. It turns out that they don't need it. Or they might want something, but it's not really what they want. And it's our responsibility to let them see what is it, or discover what is it they actually need. This one says, we need to build something. It says, I'm trying to, what are you trying? What do we want to do? What do we want to accomplish? I'm trying to make you build a piece of software. Says, well, yeah, but you haven't told me what it is. It says, well, we can build anything. Says, okay, well, can you build a piece of software that will tell you what the requirements are? If you can build anything, can you build a mind reading machine or something that can look into the future, perhaps? Certainly we have a long track record of getting it wrong, and having lots of money wasted. There's spectacular failures of project management. So we've tried to establish methodologies that make it a little more predictable on what is it that we're agreeing to build, and that can ideally guarantee to some degree that we're going to get it right. One of the earlier processes that try to give some formality on how to build it is certainly the waterfall model, that identify these very discrete steps of communication, planning, modeling, construction, and then deployment. These are still relevant. Any methodology that you apply will have aspects of these tasks, but typically they'll be in different doses, right? Of how much communication, how much planning, how much of each one of these, and in what order, right? And also the duration. Typically it used to be that it was months or even years going from one end to the other end. Today is more common that going from one end to the other is measured in days or weeks, right? That we typically try to bite small chunks of the problem, right? And try to predict no more than a week or 2 weeks ahead of what can we deliver for you in the next week or so, and we can demo for you, and you can accept that you like that or not, and then it's small enough that if we made a mistake, we haven't invested too much effort into it, and we can correct, right, and then go forward, right? So one of these steps, the first steps is communication and trying to gather some of these requirements, and these requirements are very hard to gather. Oftentimes, we do a lot of brainstorming at first, where we bring lots of folks from different areas that might be affected or might have any interest in the project, and we just listen to what people have to say, and we have a moderator that listens from different folks what they need to say, and we organize those into ideas, and typically then we follow them up with one-on-one meetings with smaller teams, to then gather some more insight. And it is the responsibility of the business analyst, or hopefully us as part of that team, that we capture formally what was said. What are the steps? What are the different goals that we're trying to achieve? And how is it that from the point of a user, from the point of view of somebody actually using the system, what are the steps that they would follow to achieve a particular goal, right? And we would typically capture that in a formal use cases, right? And this is what's going to be part of the assignment, right? The project assignment of capturing these use cases. So what is it in specifically what a requirement is? It's some formal agreement on a particular condition or a particular feature, a particular behavior that we can all agree and document in some way that can be measurable, that we were able to achieve it somehow, right? Not vague, that we don't really know if we achieved it or not. Something that can be perhaps even written as code, some test that measures that indeed we passed it, that we have achieved that particular requirement. So again, the requirements phase is by far the riskiest part of any project, and it has the most impact on whether the project is going to succeed. And we have a plethora of failures, and our success rate is dismal. It's only maybe like 20-30% of projects are considered to be successful, right? And another equal 20-30% are considered to be total failures, and maybe the rest are so that perhaps we almost got what we wanted, but needs substantial rework, to actually get to where we want to be. So we don't have a very good track record, and we're still deciding what are the best methodologies that we can follow to improve our success rate. Okay, Agile seems to better adapt or represent the way software is built. It's very iterative. It changes. It's malleable. But certainly it has its flaws and cons and pros. And certainly it's a work in progress. What is the best method, right? So maybe by the time you graduate, there'll be something else, or something Agile will have morphed into something else. Perhaps you will have a say onto where these methods go. Right? This development life cycle methods will go to improve our best chances of success. So right. So Glass's law, just general pronunciation of where can we can always trace a large amount of our failures back to the requirements phase. Either because it's fairly complex and we're trying to commit to something we don't understand, right? Or that we have an inordinate number of risks that we're not considering, new technologies, new ways of doing things that we don't have a formal process to manage things that are going to inevitably happen. People are going to change their minds, the requirements are going to change, and we don't have any formal ways of dealing with those things. That we might not be mature of an organization enough to deal with these things, right? So those are risks that certainly we need to take into account. So certainly the requirements analysis is we want to iteratively we want to create a process that can iteratively allow us to come to some confidence that we all agree of what it is that we're building. And once we've agreed of what it is that we're building, we can also agree then what is the schedule that we're going to follow. That certain things need to be built before others, and that certain things have a higher priority than others, right? That they have relative priority, and perhaps we should focus on the more priority things first. In case we run out of money, and in case certain things happen, at least we have we have tackled the things that we think are most important first, right? So those are the two most hardest things to come up with. First, agree what are we building, and then what do we build first? Where do we start? Right? Those two things are extremely important at coming up with. Part of the analysis and design is first deciding what, and also then so that's the analysis, the part of deciding what it is that we're building, and then the design is deciding on how is it that we're going to build, what infrastructure we're going to be using, what methodologies, what frameworks we're going to be building. So some of the aspects that are the hardest to come up with is that we are adverse of uncertainty. Okay, we wish we knew everything, right, and to make the best guess and the best decision now. But oftentimes these things are fairly complex, and we still need to make decisions. Right, so we need to decide what are things we don't know enough that is safe to push to a later phase and maybe tackle some of the things that we do know or we do understand. And as we progress and we understand the system better, we'll be at a better place to make decisions on the hardest stuff later on, right? And try to or that we might decide that the things that we don't know enough, we might address them as risks and decide how are we going to tackle some of the risks. Do we try to avoid that risk? Do we try to transfer that risk to a third party? Do we try to maybe prototype it, right, and lower our risk and prototype something that we don't understand enough, prototype it enough that we come to a confidence level that we feel comfortable with that risk, right? That yes, we want to try out these new technology, these NoSQL databases, but no one in our team knows that. Let's try React, but nobody in our team knows React. So those are all sorts of risks that say, yeah, I mean, I know the direction we should go, to make it future-proof, but no one in our team knows any of that. So how do I mitigate those risks? Do I bring in trainees? Do I invest in my folks that my local team? Do I start hiring folks that know this? And do we prototype certain things so that we feel comfortable going one way or the other? So there's certain things that we just don't know exactly, right? And if we insist on trying to know everything before we get started, we inevitably fall in the methodology of waterfall, right? We're not going to go forward until we fully understand what is that we're building, right? Before we invest in the next step, right? We're agile instead, says, okay, well, there's no way that you're going to know everything, and even if you finally realize that what is it you're going to build, by the time probably requirements will have changed anyway, right? The market might have moved already, your competition might have moved already, your finance won't be there anymore. Things are just moving all the time. Don't assume that things are static, right? So just start. Just start with the simplest stuff that you can tackle, right? And as you progress, right, you'll know more, right? You'll come up with an overarching vision of where you want to get to, right? And we'll start and analyzing and designing as far as we can tell, as far as comfortable as we can be. But then we'll tackle these things at a later time, with some confidence that we'll be progressing as we go. So some of the different steps involved in requirements engineering, is identifying who are the folks that impinge in our project, who are the folks that are the promoters of this, who's paying for this, what regulatory organizations are there, what laws, who's going to be paying, who's going to be purchasing the equipment, who's going to be maintaining it once it's deployed. So all the folks that are affected by the systems are certainly part of the conversation. Who the stakeholders and certainly the end users who are going to be dealing with this day to day as well. There'll be a phase where we're going to elicit these requirements. There'll be a lot of forms that we're going to be for folks to be filling out, along with brainstorming, along with one-on-one meetings, and to elicit some of these. We'll be prototyping some of the ideas, some of the user interfaces, and sending it out to folks, and and elicit some of the feedback. Says, hey, what do you think about this? What do you think about that? Identifying the requirements, constructing prototypes to elicit some of that knowledge, and then tackle things that are easy and iteratively just widen the domain of the project. So stakeholders, anybody who's purchasing or procuring or regulating, or anybody who might be opposed to the system, right? Or anybody who needs to interface with the system, anybody who needs to operate in normal or in maintenance mode. So eliciting requirements, again, it'll be lots of interviews and brainstorming and lots of forms that will be sent for folks to fill out. It's hard. Getting these is very, very hard. You have folks with disparaging priorities, right? You have folks that will have completely opposed requirements that are completely contradictory from each other. Some folks that might think that certain requirements are top priority. Some folks will say that no, that's not priority at all, right? And so how is it that you come to a consensus? So it's the hardest part of any project, right? It's requirements gathering. Problems might be way too hard to understand. Some folks might not even understand their own computing environment, or they might not be as familiar with their domain knowledge as their competition, right? So it's our responsibility to point these things out, right? that they might not be explaining things that they suppose we already know about, right? That for them is obvious, that their particular domain, that they forgot to even talk about it, right? Because it was obvious. And inevitably, requirements will change over time, right? So we need a process that deals with this chaos, right? It's a very chaotic system. What can we do to deal with this, right? So expressing requirements, there's a standard that gives some guidelines on how is it that we can formally capture these requirements, that the system shall do this, shall not do that, or must do this, or must not do that, or may do this, right? Where you can formally capture these requirements. Why is it hard to come up with this? Is that we might interpret the same sentence differently. The way you parse it, right, and how you interpret it could be completely different from one person to the next. And here's an example. Also, depending on the audience who you're talking to, they might be talking about requirements at different level of abstraction, right? If you're talking to a CEO, you're talking to sales folks, or you're talking to some VP, they might be talking about very broad, very open-ended requirements of increasing sales and or diminishing the return rate of folks returning products, or increasing repeat customers and things like that, right? That they're somewhat from a developer's point of view, it might be somewhat intangible, right? They're very, very lofty goals, right, as a vision of where they want to take the company. Right? Whereas a user, if you're talking to a user, they might be saying, I touched this button and it's not responding, or I click on this link and it's taking me to the wrong place, and they might have more day-to-day pains on how the system works. Yes. So depending on the audience that you're talking to, you'll have different viewpoints at different levels of abstraction, and so different requirements might fall in different categories. You might have you might have business requirements, right? If you're talking to a VP or a CEO, if you're talking to a user from the user's point of view, you'll have user requirements, right? Requirements from an actual person who's using the system. Typically, you would implement them using functional requirements, requirements that can actually be tangible, that can be maybe represented physically in some screens, some buttons, some language, some actual widgets, right, or certain pages that might implement certain some of these requirements, or maybe some non-functional requirements that are somewhat vague. Well, not vague, but things that are not as tangible or that are represented physically on any page, but are measurable in other ways, such as how many people can you simultaneously support. That you have to support at least 10,000 simultaneous users, or that the system needs to be available at least 95%, 99.9% of the time, or that from Mondays to Fridays, 9 to 5, it needs to be up, and that it could be under maintenance from 1 to 3 in the morning, things like that, right? They're not represented in any physical or visual, but nevertheless can be measured as performance, right? So those would be non-functional requirements. And then constraints, certain regulatory constraints or some business rules that are imposed on the systems. So there's several ways of expressing these requirements. It could be an actual contract that somebody signs and says that you will get paid when you reach a particular threshold, right? And there'll be several incentives, right? Or it could be a little more friendly as a use case from the point of view of users, right? Of what are the various goals that the user is trying to achieve. Not sure what this. Coffee and falling asleep. Right, functional requirements. So some action. That some deliberate action that the user is trying to achieve by clicking on something or dragging or interacting somehow with the system to achieve a particular goal, or some non-functional that's right, that some performance measurement, right, that it can, oh, okay, I get it, serving 45 cups of coffee per hour, right, for that particular coffee maker. Or some constraints that it needs to be, some arbitrary constraint that it needs to be ready for Thanksgiving, right? So that we're ready for the sales season at the end of the year, right? Some constraints also of safety that folks need to wear a hard hat to be for a particular place there, or because of some danger or safety need. And then and it can be captured as a contract, perhaps using some legal jargon, right? That specifies exactly and some consequences and some benefits or some incentives if you hit some of these milestones, and very, very deliberately delineated and clarified. Must haves and may have and must not have, and be very, very explicit features. So a contract style that can run for hundreds of pages and be very, very legalese. Here's a note of saying we've interviewed hundreds of users and turned all their suggestions into brand new features. Right, so a very naive way of dealing with change, right? So again, it's either contract style. Some folks, the business folks, love it. Some of us might hate it and might look for something less formal, right? So use cases are a little less formal. They're in the form of stories that give you some context of who the user is, maybe their demographics, what are their goals in life, but more specifically with the product, and tells them what are the various scenarios or different steps that the user would have to explicitly follow to achieve a particular goal, right? And the actor could be either a human being that is interacting with the system, or it could be another system that is somehow programmatically interacting with your system. Right? So an actors might be human or some programmatic organization or another system. And the use case is the collection of multiple stories and scenarios and actors that participate in those scenarios. Boundaries is it's kind of like the logical interface or box that clearly delineates where the system begins and where it ends, right? And that anything outside, right, are other systems that we might be interacting, but it's not our system. Okay? So it's a clear delineation of either software or hardware where the system begins and ends, the primary actors that are the stakeholders, and the goals that they want to achieve. So here's an example of an actual system, the SAFEHOME example of a safety set of cameras that you can operate remotely throughout the house that keep track and film, record what's going on around their house, and several scenarios that might explain some scope on what a user might try to achieve using the system, right? Might say that I'm remote and I want to be able to maybe log into some page, and once I'm logged in, maybe I'll see thumbnails of these of several cameras, and perhaps I want to be able to choose a particular camera and see live what's going on at that particular camera. Maybe I can rewind to a previous time, maybe fast forward or freeze the frame. Maybe I can zoom in and certain features, right? So all these what might be scenarios of different goals I might want to achieve, right? And each one of those goals would be captured in use cases, right? It could be either capturing this narrative of just using plain old prose, right? Or which this prose is fine. Perhaps this is exactly how it was explained to you by somebody, right? But then typically you want to distill it in a more an easier way to follow it, perhaps using bullet points, right? And each sentence perhaps being a very explicit verb phrase that somebody is actually interacting with some system and pushing something or submitting something or doing some action, and then just breaking it up into very specific steps, right? Some kind of like pseudocode that somebody can understand, and perhaps a developer can take this and say, "Oh, I can build that," right? And so without having to parse it, without having to reinterpret it, right? This has been already digested by a business analyst and distilled to its simplest constituents, right? And in each one of these, you might identify what the actor is doing. In this case, would be the homeowner, and how they're interacting with the other systems like the website or the camera and different elements that make up the system. Typically, these use cases are written in such a way that do not use things such as buttons that leave it somewhat vague on a particular implementation, right? So that you're not committing so early to a particular implementation. You might leave that open to designers later on, right? Who might decide to implement this as either a web page in a desktop or on a phone or some other user interface, right? So you can leave those decisions of actually, how you're going to deploy this and implement the framework. So you would leave it and say you would say things such as select or submit, but not click or drag, right? So because those things assume that you have a mouse or you're using a finger and whatnot, right? So you would leave those kinds of decisions perhaps to a designer who might decide what would be the best user interface experience. So those are two completely different aspects of the design, right? This explains goals and how to achieve them, and the design might decide that maybe this use case can be all implemented in a single page, or maybe we need 3 pages, right? And we create maybe a wizard that walks the user through multiple pages. That's another concern. That's a user experience concern, right? Not to be implemented here in the scenario. Make sense? So you wouldn't say here you go to the page or you go to the window, right? So those are implementation details that don't belong in the use case. Yes. Alternative interactions. Typically, the use case, those steps might at first capture the happy path, right? When things go well, and that's a very common problem in when requirements are being captured, is that they leave out the edge cases. It's a very common problem from business analysts, and this is common to all human beings, right? It's easier to write or describe something when it's already running, right? It's easier to jump in the middle of the story than to think about. Where maybe later on we can backfill some of the how do we get here, right? So it's hard to describe the beginnings and the ends, right? It's easier to describe in the middle what's going on in steady state, right? The normal operation. And oftentimes oftentimes we don't know what those edge cases are, right? And oftentimes it's very iterative. We pick out a story, and the story might only capture the happy path. Yes, you're looking at a list of students, and you pick out the student, for instance. Right? You want to select the student because you want to know the details. And so the developer is going to build it, and says, oh, but what if you have no students? What should I display when it's empty? It says nobody thought of that. And say, okay, well, the designer has to go back and maybe come up with what do you display, right? Or the developer says, okay, well, fine, we'll do this. They'll agree and they'll document the exception. And then you'll come up with says, and then it says, well, I have a list that has thousands of students. Do I have a really long list of 1,000 students? Well, there's no edge case for that. Well, we'll go back to the design phase. So what do? Do we have a really long scroll, right? Or do we add pagination? Do we add search? Nobody thought of that, right? Because again, nobody thought of these edge cases, right? And oftentimes, those won't become apparent up until you actually start building it, right? And maybe that's the place, that's the best place to perhaps come and make those decisions, right? When you're actually going to build it, and perhaps it would have been that's the agile way. You describe perhaps the happy path, and then at some point we need to come up with what the edge cases are, right? But nevertheless, those edge cases need to be documented, right? In a waterfall, you would document it very, very explicitly, whereas in agile, you would document it enough, right? You say, oh, well, there'll be a search and there'll be a pagination, and maybe that's enough, right? And maybe you prototype it really quick and say, do you like it this way? Where you have the search bar at the top and you have a couple paginations at the bottom, right? And we all understand those design patterns, and that's enough, right, for our documentation. So here's an example on capturing some of these use cases. This is a very customized use case documentation they're using their own templates. Typically, each organization will have their own templates on how to capture these use cases. We're giving you a template to follow, right? If you in your co-op or maybe you've taken other courses, if you know of other templates that are equally or even better than the ones we gave you, feel free to use those templates. But here's their template. SAFEHOME has their own in-house template where they capture the name of the use case, the primary actor, the goal, the scenarios captured down here. Here's the happy path. And on the right-hand side, they capture some exceptions. If they don't have an ID, or the surveillance function is misconfigured, or the homeowners looks at the wrong thumbnail. Some special cases, and how they will be handled. Okay, so here's some. There's the scenarios, the exceptions, the primary actors, and the goals. Here's the actual use, the steps to achieve that particular goal. Some exceptions. Another alternative way of capturing these scenarios and these exceptions is that for each one of these, if the exceptions are referring to any one of these steps, right? You might have here maybe they're referring to step number 4, right? You would document those exceptions as part of 4A, 4B, 4C, right? And so you would mention those exceptions and then maybe document them further in the exceptions section. Yes? So we're asking you for the project to create these use cases for the project that you're working in as a term project. Right. So so for the different phases of the project, the first phase will be coming up with multiple use cases and capturing some of these requirements and coming up with a preliminary interface, prototyping it, what the user interface might look like, right? Again, just get you going. In phase B, you're gonna iterate over that and start in the design phase, right? So first the analysis phase, then the design phase, where you start actually creating Java classes and prototypes and interfaces, and then UML class diagrams and sequence diagrams that design the system. And then in the final phase is the build phase, right? Which is probably going to be the longest phase. It's going to be half of the semester will be on phase C. All right. So the next couple of weeks we're going to be doing phase B, A, and B, and then half of the semester will be on phase C. So use these use cases for the user design. It's okay if you do paper prototyping or or feel free to use some of these rapid prototyping tools online. I think Mockups is a good one, and that has lots and lots of widgets that you can drag and drop, right? And you can even make them look as if you drew them on a piece of paper, and then you can export it as a PDF or as an image, right, and incorporate it in your deliverables. Eventually, what we're going to be asking for in the second phase, we're going to ask you for class diagrams. We'll ask you for sequence diagrams, where you're going to display the various sections of your system and how they interact with one another with either synchronous communication or asynchronous communication, and how they wait on each other and what messages do they exchange between the different systems. An executable prototype. So something that we can actually use and implements the requirements. All right.